Right, so we are doing the second part of hydraulic flocculator. So on the second part of hydraulic flocculator, now we have different case. For the previous part, okay, the normal ordinary hydraulic flocculator, they have basically the speed of water traveling from one channel to another and going to another channel to another until it goes out of the flocculation tank. The speed are the same. Okay, the speed is the same. Now we have different kind of speed. Okay, for compartment 1, compartment 2, and also compartment 3. They have different speed. Okay, so because of having different speeds, it will affect on the number of channels and also number of the distance between buffer for every compartment. So by the way, for questions on page 49, it is not completed. So I would appreciate if you can write down this blue text here. Okay, so n number of channels in each compartment of the flocculation tank from example 2. So we are referring to example 2. Can you write down this sentence? Okay, finish.
Belum.
All right. Okay, can I proceed?
Yes.
Okay, thank you. Okay, right. So I'd like to show you what do we mean by we have different kind of speed in the compartment. So if we look at this diagram, okay, this is a flocculation, hydraulic flocculation tank. You can see one compartment here, and then we have another compartment, and then we have another compartment. Can you see that the baffles, the arrangement of baffles are very strange or very different from one compartment to another? For example, the first compartment, perhaps we may have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say 10, okay, baffles. That means you have a very narrow arrangement of baffles. And then for the second compartment, it's a bit wider compared to the first one. 1, 2, 3, 4, 5, 6. Okay, 6 baffle, and then this one is even wider gaps. Okay, 1, 2, 3, 4, 5. So you can see the different size of distance between baffle. This is what we call distance between baffle, and hence, okay, the number of channel will be different too. Okay, for this case, 1, 2, 3, 4. You have 4 channels, and obviously you're going to have a different number of channels in this compartment. Okay, notice that the length is the same, the width of the tanks does not change, and the depth of the tank also does not change. Okay, so this is uh, whereby we have different, basically what we can say is every compartment, they have different speed of water traveling in it. Right, so we continue with that. So the first compartment, the speed is 0.24 meter per second. So this is basically
It's 12 o'clock.
This is basically the hydraulic flocculation tank. So you can see the speed at the first compartment is 0.24 meter per second. Okay. And then when it enters the second part of the flocculation tank, the speed now is 0.18. Okay. That means you must have different distance between baffles. Okay, DBB is distance between baffle. Okay, and this one DBB1 also another thing that we have to measure or we have to calculate. And then after it goes to the third compartment, also they have different speed, which is 0.08 meter per second. Okay, since we are referring to example 2, okay, so we have already calculated the width, which was 9.3 meters. It's not going to change. Okay, and the length also is 38 meters, and the depth 1.36 meter. Okay, so it's not changing. So now how do we find out the number of baffles that we have and the number of channels and also the distance between baffles? Okay, let us focus on one particular of segment. Let's say the first segment of the channel. Okay, so I highlight it with the black ring like that. Okay, so if you remember, if I zoom out, zoom, make it big. Okay, I don't know, zoom in or zoom out. Get confused whenever you teach. Okay, so that area of segment, okay, that I have already circled just now. So basically, it's like this. So this is the distance between buffer that we would like to find out at compartment 1. Oh, sorry, people. I believe you may want to take photograph of this, right? So you may do that. Have you finished taking pictures of this? Anyone?
Yes.
Okay, right? Okay, can I proceed, okay, to the next slide? Right. So this is the distance between buffer that we like to find out for compartment 1. So remember this diagram in our previous video. So that is the J, the flow rate times time. And then this is the volume of tank. And then this is the depth. Okay, the depth has been designed, so it will not change. It's 1.36 meter. Right, we know that V is equal to dBb times J times D. D is there. D is already been given. So we have to find out our volume and J. Okay, so the volume, I'm talking about in 1 second. So the volume is Q times T. So I'm assuming my T is 1 second. So this is simply 1 second. And our Q was from example 2, which was, I think it was 15 mld. Isn't that right? Can someone help me? I do not have notes with me right now.
Yes. 15
Okay,
mld.
15 mld. So simply 15 mld times 1 second. Okay, so V is equal to dBb times J times D. So dBb, something that we like to find out, is V divided by J times D. So D is given already. So we would like to find out our V first. The volume, V is equal to QT. And then this is 15 mld times 1 second. So 15 mld times 1 second. So those value is all the conversion unit from second to day, because second and day do not match. So we need to do the conversion factor over here. So day with cancel with that day, second with cancel with this second, minute with cancel with this minute, and hour will cancel with that hour. So we will end up getting a liter. Okay, our volume in liter, and that's why we would like to change it into meter cube. So we have to times with another conversion unit. So liter will cancel. That eventually you will get your meter cube, your volume in meter cube. So if you do that, you want to use your calculator, perhaps double check with me with my answer. What will you get for the volume? Okay, or if you want to write it down also, you may do that. But I think probably taking pictures would be better. Would be better because it's less diagrams, anything like that. But it's up to you. Anyone? The volume?
0.17.
17 something. Yes, it sounds correct, I think. 0.17636 meter cube. Okay, that means we have already got your V there. So the depth is there, 1.36. So it's a matter of finding out your J. And J is the flow rate. Okay, so 0.24 meter per second. And since we are assuming 1 second, so second times very simple. So that J is only 0.24 meter. And that is the reason for me to assume my time is 1 second. If you do not like to assume 1 second, does not matter. You want to assume 1 hour, 35 minutes, or whatever things that you like. But if you choose any other numbers than 1 second, your calculation will be difficult. Let's say you like to choose 35 minutes. So you put 35 minutes there, so your calculation will be a bit complicated. It cannot simply being cancel each other out. Like 35 minutes there, and this is 0.24 meter per second, so you cannot cancel. You can't easily find your total distance. Okay, if you change your time, definitely your volume will be different, and also your uh, J also will be different. Okay, to simplify the calculation, I choose 1 second, and that's the reason for me choosing 1 second. Okay, so do you want to write it down or take pictures? It's up to you guys. Can I proceed?
Oh, wait.
All right.
Okay.
All right. Can I? All right. Okay. Now we have already got your V, which is there, the D, which is there, and also our J, which is there. So it's very simple to find your distance between baffle. So distance between baffle is those value. Okay, volume divided by J times the depth of the tank. You will end up getting your dBb to be yes. Any answer? Any attempt?
0.5318.
It sounds to be all right. Okay, 0.53 meters. Therefore, the distance between baffle in compartment 1 is 0.53 meters. Okay, so that is the distance between baffle in compartment 1. We're talking about compartment 1. Can I proceed to another slide? Yes, thank you. Right? So we've done the first part, finding out the distance between baffles. So we would like to find out the number of channels. Okay? Remember, the length of the tank has already been calculated in our example 2. So it was 38 meter. So we know that the number of channel in a compartment, so I assume it to be M, times the distance between baffle, which we have just calculated, it was 0.53 if I'm not mistaken, plus number of baffle in a compartment. Okay, we know that the number of baffle in a compartment is less 1 than the number of channels. So it's actually M minus 1. Okay, times the thickness of the baffle. Nothing changed. Okay, the thickness of the baffle was 0.075 meter. Right, so we just put all that in numbers, 38 there, and then M is something that we like to find out. This is our distance between baffle, and then this is the number of baffle, which is less than 1 than the number of channels, and this is the thickness of the baffle. So with that, if you try to rearrange this, okay, you will obtain your M to be certain number. Okay, so this one times with minus 1, so minus 0.075. So you bring it here, so it's going to be 38.075. Okay, and then you just, basically you please settle the calculation. Okay, finish off the calculation. Okay, has anyone got the M? No one. No. Anyone would like to give a try on the value of M? I would appreciate that much. Yes? May I know who is that? No?
Not yet.
Not yet. Okay. You want me to simply give the answer? No, I think you better try first. No,
7.93.
is it? I do not know. Hold on. It's 69.9? 62.9. I do not know why you get 7.93. Or have I done something wrong here?
62.93 answer.
62.93 is it? I do not know. But I think this one.
Yes.
This is the right answer.
62.93
Yeah, okay. So right, that's great. Okay, so we have to round out to the number to be 63. Therefore, in the first compartment, we have 63 channels. Okay, it's a lot of channels in the first compartment. Okay, can I proceed?
Yes.
Basically, it's a repetition. Okay, it's a repetition. So I don't know whether you want to write it down or you want to take pictures. It's up to you. Okay, so we are focusing on compartment 2. Still the same diagram. The depth is not changing. Volume already we have calculated it, the same volume because we are assuming still the 1 second. The dBb is something that we have to find out, so that's not a surprise. So the only thing that will be changing is the flow rate or the J. Okay, since the second flow rate was 0.18 if I'm not mistaken, isn't that right? Okay, 0.18, the second compartment. Okay, yeah, it's 0.18. Therefore, J now becomes 0.18 meters. So with that, okay, can I proceed to the next slide? Hello, people.
Yes, yes.
Okay, there's no answer, so I'm not, I'm not sure whether I want to change to another slide or not. Right, so we have already got our J. So as usual, trying to find out our dBb. So dBb is that volume, the same volume that we have calculated. So the first one was 0.18. If I forgot 0.24, now you just change to 0.18. So if you want to slash it for, just make an indication for this is for the second compartment in your notes, in your book, if you want. So you will get your DBB to be 0.71 meters. So therefore, the distance between baffle in compartment 2 is 0.71 meter. Okay, please tell me if I can change to another slide.
Done.
Done. Thanks a lot. Okay. So I assume that everyone is okay. It's a repetitive. Okay, so we do the same thing again. The length is the same. So the same formula, but now instead of just now 0.53 if I'm not mistaken, but now since you have already got a new DBB, so the distance between baffle, so the distance between baffle for compartment 2 is 0.71. So you are solving this M, and eventually you get your M to be 48.5 or 49 meters. So with that, you know that the number of channel in compartment 2 is a bit smaller number. Okay, it's 49 compared to the previous one was 63. For compartment 1, 63, compartment 2, 49. Is everyone still okay with the lecture?
Okay.
Alhamdulillah.
Yeah.
I'm so happy to hear such response or feedback from you guys. So, can I proceed to the last part? The compartment
Sure.
3. Right, this is the compartment 3. Okay. So now again the J will be different. So the flow rate was 0.08 if you refer to the questions. So now definitely our J will be different now, which is 0.08. Can I proceed? Yeah. Any other part is not changing, only the J is changing. Okay, can I go to the next slide?
Sure.
Sure, is everyone okay? Right. So the same thing, trying to find the distance between baffle, the volume is 0.1736, I think, and the J is 0.08, and the depth is still the same, so you will end up your distance between baffle to be 1.59 meters. Therefore, the distance between baffle and compartment 3 now is bigger size, okay? There's a wider spacing, which is 1.59 meters. Can I go to the next slide?
Okay.
Right, okay? Therefore, doing for the last time to find out the number of channels, okay? So now the distance between baffle has changed again, and it is 1.59 meters. So we solve this equation, we will be obtaining a value of M to be 22.9 or 23. Therefore, the number of channels in compartment 3 is 23.
3.
Okay, because we have a wider spacing, that means we're going to have less number of channels in compartment 3. Okay, just like the pictures that I show you at the earlier part of this lecture. Okay, with that we have completed topic flocculations and also sedimentation, and I assume you to watch my filtration lecture from my webpage. Okay, and I try to put it in your YouTube as well if I know how to do it, but at this moment I just want to finish off all the lecture, the online lecture first. Okay, And then that's all, unless you have questions. Okay, no questions?
No, doctor.
Okay. Alhamdulillah. So I think I would like to stop my recording. For 27 minutes only for this part.